that we want to do now that we have our basic 3D plots is add one more feature to it in the form of a contour plot. Somewhat similar to the mesh grid that we saw, but the aim is a little bit different. So here's our contour. We've just added this to the axes, and by default, it draws the contours on the surface, and just kind of every once in a while is showing you kind of the contour of the three-dimensional surface. Now, what we're interested in is actually kind of projecting these onto the different walls of our plot. So I would like to kind of look top down and see what these look like on the bottom wall of this. I'd like to stand over here and look at what they look at from that direction and from this direction, because that tells me about the overall shape of the curve in one of the dimensions. I can see where kind of the maximum and minimum values in that orientation occur. So to do that, we just have to specify a couple of things. First is the direction that we want. If we want to change it from this default z direction, we specify with this zdir argument, either x or y. The other thing is that we tell it where if I want it projected onto one of these axes, I have to tell it where that is. So I offset the plot in that direction to wherever that axis is drawn. So for example here, the z direction, if I want these contours to be on the bottom of this, I see that that's like negative 100. So my offset is going to be negative 100. In the x direction, my offset is negative 4. In the y direction, my offset is going to be 4. And I can just see all of those in the plot here. That's where it's bottom, kind of this wall and this wall. So by adding those axes, the contours to those three different axes, here's the z, the x, and the y, then we see those contours projected onto the walls of our plots. Okay, and we can get a sense for where those kind of maximum and minimum values are occurring. But just another important tool for us, because what we're going to do is we're going to think about partial derivatives with respect to a given variable. And this is visually, at least in 3 dimensions, the idea of what we're going to be considering here. So let's do the same thing with the next function. I've defined that g now. Again, we first start with a figure, define our axes with the projection set to 3D, and we can plot the surface. We'll do it on the same domain. This function is just called g, and let's see. Okay, so now, right, my z direction seems to be around 0. Again, it looks like 4 and negative 4, and that makes sense because that's what I set those to be. So let's add a contour. And we will say the offset, actually the offset here, maybe it's negative, I don't know, it looks maybe like negative 3 or something. And make it red again. Let's see how that does. Okay, maybe we didn't. Oh, didn't call the right function there. So, okay, we don't see anything, and now I'll say offset equals negative 1. There we go. Okay, so we can see them kind of on the bottom. So let's make our surface a little bit more see-through. And let's do the same thing in the other directions. So it looks like, yeah, from offset equals 4 in the x direction. think that's drawing it there. I don't know. I think I want that still more. 4. Why didn't it go more? So equals 4. Okay, sorry, this is the x direction. And then y would be 4. Okay, and colors. Yeah, there we go. Okay, and again, we can see kind of on the wall where some kind of maximum and minimum values are going to be happening in those directions. The next thing that we're going to do is see how we can find exactly where those kind of points of maximum and minimum, either in the x or the y direction are, and they will tell us about where maximum and minimums in the z direction are by kind of isolating these partial derivatives with respect to x and y.